All right, so here's chapter 11, some more on experiments, specifically things that go wrong in experimental design, and also there's part 2 on null effects, okay, but this will cover different ways that results are confounded. Okay, so this chapter is a little different. There's not really any real-world examples that are used throughout at least the first part of the text. They're just these hypothetical, really bad experiment examples. Okay, so here's one where you have the general format is just you have a group of participants. They're measured on some things. The DV is measured on them, and then they receive some treatment or intervention, and then there's a post-test measure. Okay, so it's just one group of subjects. That's key. So maybe you have some campers. You think they're rowdy because they're eating too much sugar, so you do a pre-test, you measure their rowdy behavior, and then you reduce their sugar intake, and then you measure their rowdy behavior afterwards. Okay? Or maybe you have some depressed population, a sample of depressed women, and then you measure their depression severity, they complete some kind of cognitive therapy, and then you measure their depression afterwards. Okay? So hopefully you can see some issues with this. This is called a one-group pre-test, post-test design, and maybe you see some difference between pre- and post-test, but the issue is you can't say whether that difference is due to your intervention or due to some other factor, and we'll talk about what those factors could be. So we're going to talk about different threats to the internal validity of these studies. Okay, so one is a maturation threat. So people just change spontaneously over time. Maybe it's actual maturation, like children get older, trees grow taller, that kind of thing. People tend to recover on their own to some degree from psychological disorders. People often come in when they're at their lowest point, and it only is, well, that's kind of a different one. But there's often some natural improvement that just happens over time. Okay? So the key here is you got to have a comparison group, okay? So that if any maturation happens, it should happen equally to both groups, or the degree of maturation is randomly distributed between the two. Okay. A history threat, that's where there's some external event that happens to most of the participants or all of them, and that happens at about the same time as the manipulation, and so you don't know if any differences that you see are the results of that event, like maybe some big stressor, like there was an earthquake, and that caused people's stress levels to go up, and you don't know if that was because of that or because of whatever intervention you anticipated would cause an increase in stress. Okay, or the example from the textbook is you have maybe some Go Green campaign to save electricity, and maybe you saw a reduction in electricity usage from September to November, but you see that everybody reduced their energy usage from September to November, probably because the temperature was going down, and so they used the air conditioning less. Okay, so it didn't appear that any of that reduction was due to the campaign. It was just due to historical events. Okay. A regression threat. Okay, so there's this phenomenon of regression to the mean, and that's where you have some extreme at time 1, and then at time 2, it tends to just be less extreme. Okay, things tend to regress to the mean. Okay, I have this picture of Madden football. There's this thing in sports called the Madden effect, and I'm sure it doesn't happen to all players, but it happens often enough that it's a thing anyway, that whichever player is featured on the cover of this video game, who's, like the best or one of the best players in the league, they tend to have a bad season the next year. Okay, or sometimes, or maybe you've heard of a sophomore slump, or there's also the Sports Illustrated effect, same kind of thing. Okay, so if somebody's extremely good, 1 year, there's going to, just by chance variation alone, an extremely high values here. There's going to be a high chance that they're going to be closer to the mean the next time, just because it's statistically unlikely for extreme values to just happen repeatedly. Okay. So, of course, you got to use comparison groups in order to control for this, and you want to look at your results too, just to see does it look like there was an extreme at the pretest, and then did it go back to the mean? Okay, so now maybe you could have an extreme, like extremely depressed participants at the beginning prior to the intervention, and if it just goes back to the mean compared to the comparison group, then it was probably just a regression effect. If it completely crosses the mean and goes below, then that's probably a real effect. Regression to the mean should go basically to the mean and not to the other extreme. Okay. Attrition, so you're often going to have some participants who drop out of the study from time 1 to time 2. Okay. This is only an issue if there's systematic variation. If you remember, it's variation that's not haphazard, that people are dropping out for a reason that's related to your IV. Okay, so if you're trying to determine if a treatment is effective, if those who are dropping out are those who are responding well to the therapy, or those that aren't responding well, okay, then that's going to influence your post-test results. Okay. So there are a couple things you can do to manage this. You can, if you have some people drop out, maybe you can just take out their pretest scores too, just completely eliminate those subjects. If things are tight with your samples, and if removing people really impacts your stats, then they may be okay to remain as long as they're more towards the mean and not going to really inflate differences between the two groups. Okay. Testing threat. So that's where that's things like practice effects and fatigue effects, where just getting measured twice, there might be just some natural some improvement because you've had some practice on a task or something like that. Or you're getting bored with the task, so scores go down. Okay. Again, you got to have a comparison group. If the novelty is really important for what you're trying to measure, you might consider alternative forms of the test. So it measures the same thing. It's maybe just asking slightly different questions or something like that. Okay. Instrumentation threats. This is where instead of your participants changing the behavior, the measurement is changing. Okay, how you're measuring the participant behavior. Okay, so it could be that observers are getting lazy, or they're becoming accustomed to the experiment and they're not noticing things as much, things like that. So you may want to make sure your observers are well trained throughout the course of the study or reminded of things. If you're worried, if this is a big concern, sometimes you might say, well, we better just do a post-test only design and not measure pre and post, but just have two groups and measuring only the post-test. Or just other ways that if you just need to make sure that the measurements are equivalent, making sure that the measurements stay consistent. Okay, so you can measure that with like scatter plots and retest reliability, for example. Okay. In any study, there are 3 potential internal validity threats that you need to consider. Okay, so there's the observer bias and demand characteristics, and then placebo effects. Okay. Observer bias, if you can design your study so that it's double blind, okay, so that neither the participants nor the observers of the participants know which group the participants are in. Okay, so you, as a participant, you shouldn't know whether you got the placebo or the drug, and as the observer who's rating symptom severity or whatever, they shouldn't know whether a given participant got the placebo or the drug. Otherwise, it could be vulnerable to bias, especially if you have a lot of emotional investment in the success of a study. Okay. Demand characteristics, that's where participants are starting to figure out what the true purpose of a study is. You may want to control for that through deception. Of course, there's ethical considerations here, but sometimes that's the only way, where you have to deceive subjects into thinking that this study is about something when it's really about something else. And then you debrief them afterwards. All that. Okay, so placebo effects. These are a very real thing, a force to be reckoned with, especially in psychology. Of course, you want to make your placebo treatment, the control group, duplicate everything about everything that's in the treatment group as closely as possible, just without the active ingredient. Okay, so if you have a placebo pill and a drug pill, they should look identical. If they have any taste, they should taste identical. The participant should not be able to tell which one they're getting. Okay, and oftentimes this is measured after a study, like, hey, which one did you think you got? Did you think you got the real drug, or do you think you got the placebo? And hopefully you'll see that participants' responses to that question are no better than chance. They really can't tell. Okay. Now, sometimes you may think that there's a placebo effect, but it's actually due to other factors. So if you want to rule out a placebo effect, then you could have a no therapy group where participants just receive no treatment at all. So you could have, a real pill, placebo pill, a sugar pill that looks exactly the same and everything, and then you have no pill. And if you see any improvement in the no pill group and the no therapy group, then you could say, well, that's probably due to attrition, regression, that kind of stuff. And then any additional improvement that you see in the placebo group, that is due to the placebo effect. Okay. So you can see how much of a particular treatment's effect is due to placebo and how much is due to other factors. Okay. So that's the end of this section. We'll do part 2 as well.